we're going to discuss how you form ionic compounds with polyatomic anions. We've previously discussed the strategies for naming type 1 and type 2 binary ionic compounds, but today we're going to learn how we name ionic compounds that have polyatomic anions. Polyatomic means 2 or more atoms, so these ions have 2 or more atoms in them. Now, the polyatomic ions are things you need to know. They're things you need to memorize, and many textbooks are going to give you a table of them. And for me, I have a hard time memorizing anything unless I can figure out a pattern. And it turns out there are some patterns to these things that make memorizing them a little bit easier. So this video is going to go through some of these patterns, and I hope it will help. We're going to start with the oxyanions. These are formed when nonmetals combine with different numbers of oxygen atoms. There are some elements that have 4 common oxyanions, and there's some that only have 2 that we see regularly. We have rules for naming these. If there are only 2 oxyanions, the one that has more oxygen atoms gets the suffix "ate," and the one with fewer oxygen atoms gets the suffix "ite." If there are 4 oxyanions, the one with the most oxygen atoms gets the prefix "per" and the suffix "ate." The one with the least oxygen atoms gets the prefix "hypo," which means less than, and the suffix "ite." And then as far as the 2 in the middle go, the one with more oxygen atoms gets the suffix "ate," and the one with less gets the suffix "ite." I found all of this to be very confusing at first, but it makes a lot more sense when we look at patterns. We're going to start looking at the halogens because they have some things in common. Fill out your table and your notes pages as we go. Colored pencils may be helpful, but they're optional. We're going to start with chlorine, bromine, and iodine, and then we'll come back to fluorine, which is a bit weird. Now, on your table, the ions in the bottom row, they're not polyatomic oxyanions, but they're the regular monoatomic anions we studied when we did type 1 and type 2 binary ionic compounds. They're just there because they can be a helpful memory aid when you're thinking about charge. Let's start with the oxyanions that form with chlorine. The oxyanion that contains 4 oxygens is named perchlorate, with a "per" at the beginning and an "ate" at the end. The one with 3 oxygens is named chlorate, with an "ate" as a suffix. If there are 2 oxygens, it's called chlorite. "Ite" is our suffix. And if there's 1 oxygen, it's called hypochlorite. Hypo means less than. If there are no oxygens and it's a monoatomic ion, the suffix is "ide." The charge on the chloride ion is -1. That is also the charge on the oxy ions. Now, the "ates" and the "ites" always got me a little confused, but there is a way to remember it, and I apologize. I am going to show you an animation that you can't unsee. 8 has more than "ite." I ate a trilobite. I obviously ate more than the trilobite did because I'm larger, so 8 is more than "ite." Now let's take a look at the bromine oxyanion and see if we see something similar. The first one contains 4 oxygens. It is called perbromate, with a prefix of "per" and a suffix of "ate." The one with 3 oxygens is called bromate, with the suffix "ate." If there are 2 oxygens, it's called bromite, with the suffix "ite." And 1 oxygen is called hypobromite. Hypo means less than. If there are no oxygens, the suffix is "ide." Again, this is a monoatomic ion, but it's in the table as a memory aid. Now pause the video and see if you can work your way through the iodine family. I'll start you off. The one that has 4 oxygens is called periodate, with the prefix per and the suffix ate. Okay, you should have gotten periodate for the one with 4 oxygens, iodate with a suffix ate for the one with 3 oxygens, iodite for the one with 2 oxygens, and hypoiodite for the one with 1 oxygen. And of course, iodide is the name of the iodine anion. Now let's take a look at fluorine. We only really see one oxyanion in nature, hypofluorite. Fluorine does not usually form other oxyanions in nature. Fluorine is very small, wickedly electronegative, and it can't form an extended octet. And these are some of the reasons we don't see eights and ites with fluorine. So look at your table. What charge do you notice on the oxyanions of the various halogens? How do they compare with the charges on the halogen ions that we worked with in the last couple of videos? You may have noticed that the oxyanions have the same charge as the ion of the element they came from. All the halogen oxyanions have a charge of -1. This is very helpful to know. Here's another question. How many oxyanions are commonly found for each of these halogens, except for fluorine? The halogens have 5, except for fluorine, but fluorine's weird. Let's look at some more common oxyanions and see if we can find patterns that'll help us with memorization. Fill out your table as we go. As in the last table, the ones at the bottom of the table are not polyatomic. They are our regular ide anions. So let's look at NO3-. That is nitrate. NO2 is nitrite. Now let's look at the sulfur oxyanions. SO4 2- is sulfate, SO3 2- is sulfite, and S2- is sulfide. Let's look at the phosphorous oxyanions. PO4 3- is phosphate, PO3 3- is phosphite, and P3- is phosphide, and that is my cat in the background. So take a look at your table. You may have noticed that the charges of the oxyanions for sulfur all have a -2 charge. With phosphorus, the oxyanions all have a -3 charge, and those are just like the monoatomic ions in that family. This makes it easier when you're trying to remember the charge. But if you look at the nitrogen family oxyions, you'll notice that nitrate and nitrite, well, they both have a -1 charge. Nitride has a -3. So you're just going to have to memorize those. So let's look at what happens when we add a hydrogen. We can find some patterns here too. Let's look at the first column. At the top, CO2 3- is carbonate. But when we add a hydrogen atom, we get hydrogen carbonate, which is also called bicarbonate, with the prefix bi. Now let's take a look at the next column. We see we have SO4 2-, that's sulfate, but when we add a hydrogen to it, we get hydrogen sulfate. That's also called bisulfate. Let's see what happens if we add a hydrogen to sulfite. We get hydrogen sulfite, also called bisulfite. Pick up the trend here. See if you can figure out what the prefix bi means. Now let's look at the next column. In the top row we have phosphate, and when we add a hydrogen to it, we get hydrogen phosphate, also called biphosphate. Now what happens if we add another hydrogen? This is called dihydrogen phosphate. Di means two. Let's go to the next column where we have phosphite. If you add a hydrogen to that, you get hydrogen phosphite or biphosphite. Remember what the bi means? It means we've added hydrogen. Now, what if we add two hydrogens? We get dihydrogen phosphite. Di means two. So take a look at your completed table. What generally happens to the charge of the anion when you add a hydrogen to it? You should see that for each hydrogen you add, the charge goes up one. Now, what happens to the name when you add a hydrogen? When you add a single hydrogen atom, you put the word hydrogen in front of the name, or you can put the prefix bi in front of it. So, what prefix do you use if you add two hydrogens? When you add two hydrogen atoms, you put the word dihydrogen in front of the name of the oxyanion. Di means two. There are a few more common anions you need to know. There are some little patterns here and there, but for the most part, these will involve brute force memorization. Okay, we're going to start by going down the left column. OH is the hydroxide ion, and that is going to be extremely important when we study acid-base. C2H3O2- is acetate. CrO42- is chromate. Cr2O72- is dichromate. So with those two, we have a little pattern. They both have the 2- charge. We can also see the prefix di, which suggests that we have two chromium atoms in there. Let's go up to the top on the right. We have borate. That's pretty common. Beneath that, C2O42- is oxalate. That's one to memorize. And below we have a couple ones that involve sulfur. So the first one, sulfide, that's just monoatomic. We already know that one. But below that, S2- is disulfide. It doesn't contain oxygen, so the suffix is just "ide." But you'll notice because there are two of the sulfurs, we have di as a prefix. Now below that is thiosulfate. It has oxygen, and the suffix for this particular anion is 8. Now the thio means sulfur. So if you see thio in the name of a compound, you know they're talking about sulfur. Now let's go to the next section. MnO4- is permanganate. Now below that we have Cn-, that's carbon nitrogen with a 1- ion, that's cyanide. And below that we have SCN. Here we see that word thio again, and thio means it contains sulfur. This is thiocyanate. We'll go down to the next row. We have azide. That's N3-. You'll have to memorize that one. And below that we just have our regular nitride, which is a monoatomic anion. Now azide has a minus charge just like the oxyanions did, but nitride has a 3- charge, so again, something you need to memorize. Now to the right-hand side, P2O74- is pyrophosphate. According to Wikipedia, the pyro comes from the word fire or heat, and the ancient Greeks used to make it by heating phosphoric acids, hence pyrophosphate. Let's go to the next section. We have O2-, that's oxide. Then we have O2, 2-, that is peroxide. The prefix per apparently refers to the extra oxygen atom. Below that we have O2-, which is superoxide. Finally, we need to go over a couple of polyatomic cations you need to know about. The first one, H3O+, is hydronium. We are going to be seeing this a lot when we talk about acids and bases. Now the second one, NH4+, is ammonium, and you'll see a lot of this one too. So there you go. Those are the names of the common polyatomic anions with a couple bonus cations thrown in there for fun. There are others, but these are the ones you'll see most often. Now, when you name ionic compounds with these polyatomic anions, it's very similar to the way we name type 1 and type 2 binary ionic compounds. The cation goes first, and it usually has the name of the element. The polyatomic anion goes second. Now take a look at these examples. For some of these compounds, you'll see the ion in parentheses with a subscript. The subscript denotes the number of that ion in the compound. For example, in row 2, you have barium phosphate. Now the subscript 3 next to the barium means we have 3 barium ions. The subscript 2 that's next to the phosphate ion in parentheses means we have 2 phosphate ions. The next row is similar. You'll notice that we have an ammonium ion in parentheses with a 2 subscript. That means in this particular compound there are 2 ammonium ions. You should now have a start on learning polyatomic ions. These take some practice and a lot of memorization, though you can use flashcards to help you. This is one of my favorite flashcard games, but there are also a whole bunch on Quizlet and in other places. So good luck and practice, practice!